Advent of Code 2024, day 24, crossed wires. This was by far the hardest challenge of the year, which I guess makes sense for day 24. Let's take a look. It starts off deceptively simple. So in part one, I'm going to have a series of wires that connect some gates. And so there's three types of gates. There's an AND gate, an OR gate, and an XOR gate. These are all very familiar terms to me, basically. And the output is on only if both inputs are on, or the output is on if either input is on. And then XOR is the output is on if one or the other, but not both is on. So both off results in off, both on results in off, one or the other on. And so we're going to get a series of initial values for like for some X gates and some Y gates. And then we're going to get, and then there'll be a double line break, and then there'll be a series of the gate definitions. So X0 and Y0 leads to Z0. And they're basically there's going to be a larger example here. There's going to be intermediate gates and things. Gates can be any three characters, numbers or lowercase letters, it looks like. It'll be important to note the inputs are all X's and Y's, and the outputs are all Z's. So eventually we want to find these Z's, and the goal is, if we run, there's no loops or anything, so just everything goes nice and linearly. So you take all the X's and Y's, run them through the thing, and eventually you get all the Z's. And the goal is to take those and produce a decimal number, which then can convert that to decimal. So in this case, Z0 is the least significant bit, Z1 is the next least significant bit, etc., all the way up to Z12. That's part one. Part one's pretty easy, and I have already solved this. I solved this on the actual day. I just couldn't record until now. So let's take a look here at the solution. This is one where I spent, I think, 3 or 4 hours. Part one, probably 5 minutes, but the part two is a long one. I'm gonna try to walk through the process and show the analysis, but I already got the code here. I'm just going to show it. So the way I set this up was I actually created a connection class. It just felt you could do this with like some tuples and just knowing the orders, but it felt nice to me to just have a connection class. So I did that. It takes input, output, inputs, two inputs, an operator, and an output. I have this operations helper, which is just going to let me, and I'll show how I use this later, but I can basically define the functions for an OR operation takes an X1 and an X2 and returns the bitwise OR of those values, etc. I'm going to write a run wire function, which we'll come back to momentarily. And then, so I'm going to open up my data and read it in. I just use regex to find all three characters, colon, and then another, if we look at let's find the example here. And then another value, 1 or 0. So here, so that's what this is. This literally says 1 or 0. And I capture those into pairs, and I loop over them and create a dictionary here called init. And then I split all the data on double new line, and I get a bunch of lines. That's my mapping string. I'm going to create a map, wire map, which is just a dictionary. I'm going to loop over every line in my mapping string, and I'm going to, I can use split, just split it into input, operator, input. This is the double arrow and output, and then save that as a connection in my wire map based on, so now I can say for the output Z4, give me the connection that defines what it is. Having that wire map is what allows me to then have run wire. So I can say for the connection Z4, it'll say, well, if Z4 is in init, which really means if it starts with X or Y, but we'll just say if it's in the initial values, we'll return the value of the wire. Otherwise, I'm going to get the connection for that wire, and I'm going to then call the operations, this right here. So I'll say of con.op. So if it's op is an and, it'll get the and function. This part right here is a function. And then it takes in the two inputs, X1 and X2, which are going to be the input and the input. And I'm going to call run wire on those so that if it's a X, it'll come here and just get the value off of init. Otherwise, it'll recursively work down, and I'll get, eventually get an input there. So then I can simply run wire for, let's work this through backwards here. So here I'm going to take every wire in the wire map if it starts with Z, and I'm going to sort it, and that's going to give it to me and I'm going to actually want to reverse that because I want to get, I want my result to be the 12, like if I'm going 12 to 0, I want the 12 to be the first one because that's how we think about bits. So I'm going to reverse it, and then I'm going to run wire on each of those things. So that will return to me integer values for each z. And then I'll just take those and join them into I'll convert every integer value to a string with the map function. I'll then join those strings with an empty string, and then I'll convert it to an integer at base 2 and get part 1. So we can do Python. In fact, I'll do a my -I here. I'll show you some of that other stuff. If we do on the example.txt, we get 2024. We can look at result. Oops. The result is just this series of ones and zeros that comes out of, so this is the bit Z0, Z1, Z2, etc. And it maps what we had on the input. If I do this on my input, it's incredibly fast, and it should give the same answer I got here. Perfect. So part 1, pretty, not too hard. Part 2. It turns out, actually what we're trying to do is make a computer that adds 2 numbers. So the x, there's the same number of x's and y's as inputs, and we're going to add them to get a z value. And the problem is that there's 4 pairs of gates that are swapped by accident and have been messed up in our diagram. And so I need to figure out which 4 gates need to be swapped back and fix them. And the thing I'm actually going to turn in is going to be a comma separated list of those gates. And that's it. So this was really hard. And I'm gonna sort of walk through what we looked at here. So the only thing I changed at the top part here was I did add there's 2 things I had to add to our connection class. First, well, I guess okay, 2 additions and 1 change. 1, I decided to start tracking inputs as a list rather than as in1 and in2. And the reason that's helpful is because the order doesn't matter on those, right? Like I really care if something is an input or not. And so it was just easier to be able to do like in list versus like equals in1 or equals in2. And so I did some refactoring in here. Let's see. Whoa, how did I get so far down? Where did I make some connections? Here. So here I have to say I pass in a list of those things. So I'm passing in lists there. And then what do we use? Wire map. So here I get wires, and then here I just have to refer to these things as ins1 and ins2, ins0 and ins1. So it actually is more difficult for part 1. Oh, actually, I'm not even in part 1 yet. I'm in so for part one, it literally didn't matter because I just map it here. I guess it slightly changes in my run wire. Is where I need it. Now that's where I need ins0 and ins1. So it's slightly harder. Part 2. So first thing I did was create a run wire 2, and that effectively is the same as run wire, except I'm able to take in a dictionary, and this dictionary is going to be, I'm basically throwing out this because I'm not going to worry about this right now. Because I need this to work mathematically for any input. So I'm going to have this thing take a dictionary, and now I can run wires under a given initial conditions. And so this allows me, otherwise this is basically the same, right? I'm basically going to check and see if it starts with X or Y and 2 digits. I'm going to get that. And then I'm going to keep the alpha value and then the digits separately. That's var and num. And I will use my initial value. It's going to be a dictionary that takes X or Y and then a number, and then that has the value. Otherwise I do the same thing, except for this is literally the same line as this, except for I have to pass in a init to both calls to run wire 2. I have a simple helper function here just so I got tired of trying to z-fill over and over again, so I made a function to make a wire. But here's the interesting part. So I'm going to take this, my mindset here is if I'm adding binary numbers, the only thing that matters is for any given bit in the chain. So I'm going 5 bits in. What do I care about? Well, I care about the X5, I care about the Y5, and I care about if a value was carried from 4, right? So if I carried a value from 4, I could have a 1 there or not. So I have 3 potential binary spots. And so what I'm going to do here is I'm going to isolate that by basically setting a list that is entirely nulls, except for I'm going to mess with the X value for a specific spot, the Y value for a specific spot, and the carry value for a specific spot. And the way I do that is to say, so I have 3 loops here. So we're going to have 8 possibles, right? 2 x's times 2 y's times 2 carries. And for each one, I'll say a init x is going to be a bunch of zeros, 44 zeros, minus n, so some number of zeros. Then it's going to be the x value. Then it's going to be the carry value. And then it's going to be a bunch more zeros. And the kind of a trick here I'm doing is I'm not actually trying all possible combinations of the previous bit. I'm just going to have them both on or both off. Because if they're both off, no carry. If they're both on, they carry. No, there's other situations where like that carry bit was on and one was on and one was off. I'm not going to worry about that. I'm just checking all possibilities for my 1 bit range. And so effectively what this is going to do is going to set me up an init x and y such that I get what I'm looking for. You can run through and actually make sure this math works. I actually had to reverse it here. And so anyway, that is what ended up working out for me. Probably clean this up a little bit. Then what I'm going to do is I'm going to call runwire2 on z to my n. So I'm checking the nth bit, and I'm going to pass it these init values. And if I get to a point where z is not equal to x plus y plus carry mod 2, then I return false. Because z, the output bit, z5, has to be x5 plus y5 plus the carry from y4 from 4. And so I can do this and I can find where my mistakes are. And so I make a simple loop here that says, you know, for every range, 45 is just, if we look here, the x's go up to 44, the y's go up to 44, and if we do z, we do a control F, where z 40, there's a 45, and that's it. So there's no, 45 is the highest. So we need to check the first 0 to 45, 0 to 44. All right, so we can run this. And if we do, oops, I didn't get out of here. We're basically throwing out the example input at this point. And we can see we get failures. And we get failures at 15, 16, 21, 22, 30, 31, and 34. Now, only 4 things are swapped. But if you think about it, swapping, messing up one thing can have propagation issues, and it really can propagate to the next one. It probably won't propagate beyond that. So it looks like 15 is probably messed up, 21 is probably messed up, 30 is probably messed up, and 34 is probably messed up. So I think I found 4 places where I got broken logic, and that's cool. We can comment this out now, and let's move to the next next thing we did. So now I wasn't quite sure. Okay, so my first thought was, oh, I'll just try getting a list of all the wires involved in making 15. And this, my first thought was, once I find those wires, I just try to practice swapping them, but it wasn't that easy because I actually can swap with other ones outside of that. So only one of them is actually broken. So that didn't work out, but it's still valuable to do. So we'll see. We're going to turn on, I wrote a get wires function, and all it does is you give it a string, like so say Z7, and it will start with Z7 included, and then it will get the connections, and it will say for each the connection, you know, this could be cleaner. Oh, so okay, actually, let's go back. So then I say if connection is in the wire map, I'm going to call get wires on that input, and I'm going to basically the returning set, I'm going to OR in. So basically that's combining the set. And basically it's going to start off with the wire give it, and it's going to take all the wires that come from figuring out its inputs. So I can get every wire involved in getting a given input. And so if we do this, let's see, minus I. So now I can say like get wires 6. Nope, Z06. And those are all the wires that contribute to Z06. Now, if I do get wires Z05, I get all the wires that contribute to Z05. And these should overlap greatly, right? Because all the ones up to Z05, to get Z6, I'm gonna have to get Z5, I'm gonna have to get Z4, I'm gonna have to get Z3. But what's cool about the reason this works as sets is now I can do get wires on Z05. If I subtract them, I'm gonna get the ones that are uniquely, these 5 are uniquely contributing to Z6. And so in fact, I make this nice helper function here. I call print impact connections. I don't know if my names are good, but basically I'm going to do just that. I'm going to take some n, I'm going to make the wires Zn and the wires Zn minus 1, and I'm going to subtract them to get the wires that uniquely impact n. And then I'm going to print out the wires involved in that. So let's run that, uncommented that. I can now do it. So I can do print impact connections on 6. And you can see I get the same 5 values here, but now I can actually see what they are. If I start to run this, if I do 7, if I do 8, I'm going to start to see some patterns here. If I do 9, each one of them has 5 inputs that are impacting. I can see each one of them has an XOR of the input, the X, and so the impact Z6 has an XOR on Y6 and X6, and that makes perfect sense. So we can see that's here, that's there, that's there. So each of them has that. Each of them also has a and on the previous bit, and on the previous bits, and on the previous bits, etc. So I can start to figure out what these patterns are. Now let's take a look at one of the ones that was failed, 15. 15 is complete. So I can start to figure out, okay, what's missing here? What's wrong? What should be there? And so I can say like, oh, I got my XOR on the bits. I've got my and on the previous bits. Those are right. So I can start to work backwards and figure out what's broken. Now we can do that manually, but we can also, let's see if I can, I basically said, okay, that's useful, but let's see, we can comment you out. And come down here and we'll do the now this is where we actually get to fixing. Here, uncomment all of this. I think that'll work. And I guess we'll go ahead. Well, let's go ahead and explain. So fix bit in says these are the expected values that I should have. And again, I just gave them names, but like ZN is the XOR of where's you basically can trash these things down. I can map all these out. I don't know n XOR. Oh, here we go. Okay, n XOR is the XOR of xn and yn, like I talked about. Zn, we can see there's always one of them in here. Let's go back up to one of the valid ones. Z6 is going to be the XOR of 2 things. One of those things is the XOR of the bits, and the other one is this OR value. So I can start to map out patterns of what it should look like. And so, and I sort of define these things as, I wrote 6 of them. One of them actually it comes from the previous one, and it can't be the problem, because if it was the problem, it would have crashed the previous one. But by defining these things, I can now start to find the right wires that I would expect to be there. And so a couple helper functions. I make a find wire function that takes optional, in fact, I could see, this would be string or none. Rather, this was none. This one is going to be an input will be string or none. And this one will be string or none. So now we have types. These are all optional and they take strings. And so if for each wire possible, so I'm going to loop over all the wires. If op is set and op is not equal to, if it doesn't match, then continue. If the input is set and the input is not in the wires, continue. Basically, I can set the inputs and find the exact wire I need out of my map. I could have probably set up my data in a different way in the first place to avoid needing this function, but that's what I went with. And then I made a swap function to actually fix it. And all I'm doing here is going to say, if I have 2 wires input, I'm going to say wire map of W1 is equal to, swap these 2 these 2 things. Okay. So now I can start to say, okay, well, I expect my previous and to be the operation and the wire x, and it needs to have the wire x n minus 1 and y n minus 1, because I know I need that thing. I need to have a previous XOR, which is the again, setting up the op is XOR, previous x and y. Then I need to have a wire, I need to have something that is an AND operator with the previous XOR value. I need to have, and so I'm working up these patterns that I need to know. I need to have this n XOR, where it's just the x and y values XOR together. And so I can get to the end here and I can just say, okay, well now my Zn is going to be the XOR of this one and XOR and into and M1. Well, sometimes if those aren't set right, then this is going to end up being none. It's not going to find the right wire. And so then I can say, okay, what should it be? or I'll get that wire out of the map, and I can say I need to swap it so that that swaps here. Um, Otherwise, if the z'd out doesn't match the wire that should be, the wire that it should be, I can also swap them there. And that actually turned out to be enough to fix it for me. I think it's possible there could be more errors up in here, that I might need to do some more backtracking to figure out other places it can fail, but it fixed all of mine. And so once I have to swap, which is the two wires I need to swap, then I can just pass them to my to swap and return them so that I can collect them. And that gives me this part 2 where I will loop over all 45 possibilities. If it validates, great, continue. If it doesn't validate, I'm gonna call fix bit on that bit, getting back the 2 options I swapped, extending them into there, and then I'll print my sorted flag. And so let's get rid of the dash I. We get here this string right here, CQK and hopefully that matches what I have down here, CQK FPH 2134 were my last two. Yeah. So didn't feel like it was worth it to go through and recreate all of this again from scratch, but hopefully you got a feel for the logic I took. Having watched some other solutions, watched and read some other people's solutions, I think it's possible to, I think some people took the approach of assuming the machine had to be optimized bitwise addition, and you can just sort of work through the math to say, okay, but what does it mean to do bitwise addition, and that actually and work out and actually arrive at like these 5 operations for each bit, and understand mathematically why it should be these. I didn't take that approach, and the problem with that is that it does assume it's used doing it optimally, right? Because there could be extra additions in there along the way. You could not something and then and it together, and then do things that ending up being null, but that make it extended. So I kind of worked backwards, just saying, okay, show me where it doesn't validate. Now let's look for patterns and see if I can fix it that way until it worked. Their way is probably cleaner, and maybe there's a reason it has to work their way. But anyway, interesting problem. I thought it was incredibly challenging, but fun. I had a fun time doing it, even if I was frustrated a lot. So that's it. Thanks again for hanging out with me, and I will be back with one more video in the series for day 25, which was much easier. So I'll see you then. Thanks. Bye.